Hello everyone, it's Chris from Military Aviation History, and today I want to address something I get asked about a lot. That being, of course, German World War II aircraft engines. Take your Daimler-Benz 601, 605, the UMU-213s, the BMW 801s, and so on. Plus, of course, the use of those two special substances, GM-1 and MW-50, to boost the performance of these aforementioned engines. And I think those are some really excellent questions because engine technology is at the heart of aircraft design, performance and capabilities. And actually we don't talk about it enough, even though if we talk about aircraft, we really need to start talking about engines before anything else. But that topic in itself can be broken into a few sub-chapters. What interests me, for example, in aircraft engine? Well, those are, for example, the strategic and the operational aspects of engine production, the logistics involved, the operational performance, and of course the associated developments throughout the years. But beyond that, there are, of course, the nuts and bolts sort of engineering aspects, and I think I know someone who is a lot more qualified than me to talk about those. So instead of me answering this question of what GM-1 and MW-50 is, what it does in your German aero engine and why it was used, I thought I'd invite Calum Douglas, who is an engineer, and he is also the author of this book, The Secret Horsepower Race, Western Front Fighter Engine Development. This is a book that came out recently, actually only a few weeks ago, and I ordered this book back in April as a pre-order, and I've been in touch with Calum Douglas for some time. So I thought, you know what, I passed this question on to him, and he sent me back a really good answer in video format with plenty of insights that I think a lot of you will enjoy. So enough from me, over to Calum Douglas.
Hi, my name's Calum Douglas, author of this rather weighty tome, The Secret Horsepower Race, which is about World War II engine development. And Chris from Military Aviation History has asked me to do a short video talking about GM-1 and MW-50, which is nitrous oxide and methanol water injection. So we're not going to cover all the operational aspects. It's really just to give you a bit of a feel for what they actually were, how it was used and why it was used, going back to the original documents and avoiding the typical Wikipedia type mistakes on this stuff. So let's get started. So the first thing we'll look at is GM1, which stands for Göring Mischung 1, which is Göring's mixture number 1, which is just because when it was developed at the Göring Institute, and basically the guys there decided that it would be a good career move to make sure that they mentioned the boss. So I don't think Göring had anything to do with this. So why might we want to use nitrous oxide? Well, a big problem we've got with aeroplanes is that they have to go quite high up in the air. So that's, I've scaled it approximately, but that is basically the height of Mount Everest. And when we're down at sea level, we've got 1 bar of atmospheric pressure. So this is a very happy situation for our aero engine because we get lots of air into the engine and we make lots of power. As you want to fly higher and higher up, the air pressure goes down and down and down quite dramatically. And so if you want to fly really high, something like that's obviously the SR-71, you can see when we get up to 25 kilometers, the air pressure there is something like 20 times less than it is at sea level. So, and this is a little Cessna here flying at 5 kilometers. So some people do get a bit surprised when we look at how far up World War II aircraft can fly. I've put in a PR Spitfire, but also some TA-152 variants would also reach the same altitude. So it's about 15 kilometers, and if we look at this graph, basically we've got something like 6 to 8 times less pressure at this altitude than you've got at sea level. So this is a big problem, because if we've got less pressure, we've got less density, which means that for the amount of air being sucked in, there's less oxygen in it, and we can't burn the fuel without oxygen. So if you're flying up here, you've got a big 2-stage supercharger, which is basically 2 hair dryers connected in series, and this does a reasonable job of stuffing the air into a smaller volume so that we've got more oxygen in the cylinder. But we can do more. And the first person to really apply this to an aeroplane engine was Dr. Otto Lutz at Technical University Braunschweig in the late 1930s, and he published a lot of his research in this very prestigious German academic journal in the war, the Deutschen Akademie für Luftfahrtforschung, which is just a sort of German academy for aeronautical research and sciences. And basically what he came up with is using nitrous oxide to boost engine performance. So what's it actually doing? Well, there's 2 things it's doing to make the power go up at the start. So basically the first thing that happens is that it evaporates, because it's stored at usually at a low temperature. So when that evaporates, it cools down the air into the engine, which makes it denser. Basically, when it's inside the engine, the nitrogen and the oxygen separate, which is an exothermic reaction, which just means it produces heat, and these 2 things disassociate, so they split apart in combustion. So an engine is a heat engine, so if you put more heat into the combustion cylinder, you get more power essentially. And the second way it creates more power is that the oxygen content of nitrous oxide is 36.4% by weight instead of 23% of air. So this means we can burn more fuel. So these are the 2 mechanisms by which the nitrous oxide is actually producing more engine power. So we do, obviously, to take advantage of this, actually have to also inject more fuel when the nitrous oxide is going in to get the full effect. So the first time this was actually used operationally is really towards the end of what would be called the Battle of Britain 1940. I don't have exact dates, but if we look at the German Air Ministry meeting minute abbreviations, not abbreviations, the minutes, the abbreviated minutes, we can see here that the first code word for nitrous oxide actually wasn't GM-1. In the very early days it was called Mona. I don't know why, maybe someone does. And basically what they're saying here is that the installation of Mona, nitrous oxide, is only for 3 staffels, for those of Mulders, Galland and Wick. And as most of you probably know, these were 3 of Germany's most famous aces at the time. So it's quite interesting to note that this stuff is really being given to just a very small number of aircraft in these very elite units. So it wasn't a fair fight by any means. They also produced a promotional video at the Hermann Goering Institute to show everyone what they'd been spending all the money on. And this is a Messerschmitt 109E, which has been filled with GM-1. So that, if you look there, that's the actual little filling cap that has to be removed, and the tanks are just in the fuselage behind there. And there's a chase plane with a camera, which probably a Messerschmitt 110, and there are 2 Me-109s here you can see. And the one I've circled in red, the pilot is basically just going to unscrew a valve in the cockpit, which is going to allow the nitrous oxide in, and it basically vanishes off into the distance. So make quite a big difference. So along the bottom here we've got the speed of the aircraft, and here we've got the aircraft altitude in kilometers. Ohne and mit means without and with. So for example, at 8 kilometers without GM-1 we are doing in a Messerschmitt 19E about, say, 545 kilometers per hour. If we turn it on, we're doing 600. So basically we've gone plus 50 kilometers per hour, and that advantage increases as we go up because the oxygen content of the outside air is going down and down and down as we go up. So this is the advantage of it. I think this is probably a fairly extreme example. I suspect that they may be putting in more GM-1 here than was done operationally, because as you see at 11 kilometers the speed advantage is really about 150 kilometers per hour, which is really a lot, and I think that might be with a very large dose of GM-1, which may have been more than was used operationally. Now looking at where this stuff was actually made is quite interesting. So this is just a little graph from one of the German wartime reports, and it's all pretty secret, and I don't know what H, 0, V and M mean here. Maybe someone can tell us. I suspect they're code letters, but I might be missing something. But basically, if we look at the little key here, the circles are where the stuff's being made, the square is where it's being stored, and the diamond shape is basically where everything's gathered at the front for the aircraft. And the two lines here, first one, the solid ones, that's the lower one, so that's nitrous oxide stored at low temperature to make it a liquid, and the dotted line is nitrous oxide stored as a liquid by being stored at high pressure. So there are two ways you can make it a liquid. You need to either cool it below its liquid point, or you need to pressurize it. So there were two different systems in use at that time, and this is just a little translated paragraph for you from the original report. So they're just saying that it's pretty good for availability, 60 tons a day from two places in Germany and in occupied France. So I've overlaid this map with Google Maps, and it's only very approximate, but I think the two sites in Germany appear to be Frankfurt and Speyer, and in France, Lille, Rouen, I don't know how to pronounce these, Louviers and Tournai. I'm sorry if I'm pronouncing that wrong, but I think that's approximately where these factories were. I would imagine today you might find these towns have still got some sort of industrial area nearby. Maybe some natives of France can give me some tips on these, because I haven't tried to visit these sites. So one of the first Messerschmitts that were captured in England with the GM-1 system crashed in Dorset on the 9th of June 1941, and this system had GM-1 kept as a liquid under pressure. What this basically means is that the tanks that store it have to be really thick, because it's high pressure inside, and they'll burst if they're not very thick. So the tanks are quite heavy, and also if they're hit by bullets, which is quite likely if you're a Messerschmitt pilot or any fighter pilot in the war, they don't react very well. So there are plus and minus points to storing it under pressure or as a liquid. The early systems used by the Luftwaffe all stored it under pressure, and later on they moved to storing it at low temperature, but just in atmospheric pressure, so literally just sort of pouring it in out of a bucket almost, if you like, into the tanks, which were insulated. So we've got 3 tanks here, and the pilot has this control cock in the cockpit, and there's a pressure gauge, and he turns this on, and the GM-1 flows through into the engine, and the engine also needs some fuel enrichment to take advantage of that. It's quite a funny story here, because British air intelligence is normally pretty good in World War II. They had some very well qualified people, but they really dropped the ball with nitrous oxide. It's quite embarrassing to be a Brit if you read the papers on this. So the German pilots were sworn to secrecy, and in fact they weren't told what the system was. So the German pilots, unless they were very well connected and word got through to them, they didn't know it was nitrous oxide. So they were given a keyword to tell the British when they were captured, which obviously happened. And Erhard Milch said that under no circumstances did he want the British finding out what this was. So basically they were told to call it the ha-ha process, which is an incredibly bad code name because nitrous oxide's also known as laughing gas. It was used as an anaesthetic as well. So it's a really shockingly bad code name. They still didn't get it. It took them really a good couple of years before the British realised it was nitrous oxide. When the things crashed, the tanks would always be ruptured, and so they wouldn't really be able to find out what the contents were. So it's quite funny reading these transcripts actually. So this is a bit later on in the war. So this is 30th of May 1943. So Junkers Ju-88, which had nitrous oxide system, and the pilot, incidentally, Simon Siegfried, if you're interested, and that's the Werk number of the aircraft. And this is an RAF technical officer, and he's found a tank here which is not actually the nitrous oxide tank. So, because this is a heavy compressed bottle, and by this point they were using it stored under low temperature as a liquid in a thin tank. It's very lightweight and is less susceptible to rupturing if it's hit, and you get more engine power because you're storing it at low temperature. So it cools the intake charge more when it flows into the engine, but it has other difficulties. What he's found here is that it's one of the compressed air bottles that were used to push the GM-1 out of the tank, because if you're not storing it under pressure, you have to encourage it to go into the engine. So the Ju-88 system had compressed air bottles, and these forced the GM-1 out the tanks through into the engine. So that's what he's found, and he knows it's a bit special because it's got no markings on it. And normally the oxygen cylinders would always have the markings on, so the ground crew in Germany or in any country know what the bottles are to refill them, so they don't refill it with something that they shouldn't. So he knows it's a bit special because it's got no markings on it. And if we look at the GM-1 system that's installed in the TA-152H, you can see the same thing. So these bottles here, these are the compressed air bottles used to force the GM-1 out of the tank. And this is the main GM-1 tank here, called number 2, and the nitrous oxide is stored in here at low temperature, not under pressure. And the kind of results you can get, so this is just looking at the BMW 801, so this would have been some of the later FW190 models, and basically these are the power curves. So the solid line is owner GM1 without, dotted line MIT with, and basically it's only used at high altitude, principally because it's an oxygen carrier. So although it raises engine power, the best advantage is to use it at high altitude when you've got very little oxygen in the atmosphere outside. You can use it at sea level to boost the engine, but if you read my book, you'll understand that Germany had a lot of problems with aero engines at the time, and they couldn't really boost the power at sea level too much without damaging some of the engine components. So this is why it was really strictly only used at high altitude, although it could be used in theory at sea level. So if we look at the dotted line here, we've got something like at 8 kilometers. If you engage the system, we've gone from 900 PS to 1200 PS. So it's basically 300 horsepower. So it's a pretty decent advantage. It's very, very useful amount of power. For the FW190, it's supposed to have only been used at the A8, which comes in 1944, but I've actually got Focke-Wulf drawings for GM-1 tanks which are dated 1942, so I'm not completely sure what happened there, if there was just a big delay with the tank manufacturer, or if the use started maybe informally quite a bit before 1944. So I'm not quite sure about that. Further research is required. Let's have a quick look at MW-50. It's methanol water. The 50 is because it's 50-50 water methanol. You don't have to have that. That's just the usual ratio that was used by the Luftwaffe. And so basically to raise the power, it's basically the latent heat of evaporation. Basically just means the stuff's a liquid. If it becomes a gas when you inject it, it changes the phase, and when you have a phase change in a liquid, it needs a big amount of energy to change it from one phase, a liquid, to a gas phase. So it absorbs a lot of energy to do that, and it's about 2 kilojoules per kilogram of the stuff you're putting in. I can't give you a temperature drop from that because it depends on what the flow rate of what you're putting into is to work out how much the temperature would be dropped, but it's a lot. And in fact, according to my research, at least in aero engines for fighters, it was first proposed by 2 BMW engineers, actually, Singelmann and Zaborski, and first tested on a Bramo engine. And you can read more about that in Air 4100 at Kew National Archives. And so if you look at the system in a 109, basically you've got a tank that sits with methanol and water in it behind the pilot. You've got the supercharger, and the pilot has 2 different switches, one to energize the system and one on the throttle lever to make the methanol go in. And these parts actually look like this, so thanks to Chris Starr for showing me these bits. So these are original Messerschmitt 109G MW-50 components. So you first energize the system. This switch is on the cockpit front panel, ein, so it's on, and then this switch here is on the control stick, and you press it and that activates the system. The methanol flows through this valve here and through a filter, and then it goes into the pressure gauge. So that would be sitting in the cockpit of the 109G facing the pilot, obviously. So that's basically how it works. In terms of BF109 types using it, if you look at the DB605 engine designations, the introduction of M tells you that it's got methanol water injection, AM, ASM, etc. This is approximately from the G6 onwards, and the K, which very limited production of. So it gives you a really big boost in power at sea level. And basically in this example here you're looking at about 300 horsepower, so it's a similar advantage to the nitrous oxide. It's dependent on the flow rate, but the balance you've got in an aeroplane is weight is a huge issue, so there's a balance between how much power you can get and how long you have it for. So they worked out a kind of best case scenario of how much power is useful and how, if over what period of time. So they just worked out that 300 horsepower is a good bet to have, because you could have it in the plane for a reasonable amount of time without it running out or being too heavy that you can't take off. So about 10 minutes. So we can use both systems at once. And so if we look at the TA152H, so we've got a GM-1 tank here, and we've got fuel tanks, and there we can see MW-50 Behälter, so that's a tank, 70 litre MW-50 tank. And there's a bit of debate about how much were in the tanks. It seems to change quite a lot between the different models. This is a slightly simplified power graph that's in some of the British files on the system. It's, I think, pretty similar to a UMO 213EB, so, but for the purposes of explaining it, it's pretty close. So basically that's the normal power of the engine. If you just put the methanol water in, you get about 100 horsepower, and that's not with putting the boost up, that's just because the methanol has some fuel calorific value, so it increases the power a little bit. And if you then, once you've got that, also put the boost up, and you've got more main fuel going in to put the boost up and more power, you can see we're going from 1850 to about 2250 horsepower for this particular engine. It depends on which variant. And you can see with the GM-1, they did eventually get to having a couple of different flow rate settings, so the maximum was about 300 horsepower. And this is a graph covered up by my ugly face here of a BMW 801E, so just so you can see it's the same kind of system here. So you can see the approximate change there. Yeah, so that's 2000 to 2250 or so. So just to clarify about the Tier 152, this is quite a nice graph. It just shows you which of all the different variants were actually fitted with GM-1 and MW-50, because it's not all of them. So you can see it's basically only the H1 and H2. So all the other ones didn't have both systems, and as far as I can tell, it does look like the Tier 152 did have 85 litres of GM1 and 70 litres in the wing of MW-50. So I hope you've enjoyed that short presentation. We can talk about lots more details, and thanks very much to Chris for inviting me to talk to you about this stuff, and I hope you enjoy the video. Bye for now.
Big thank you to Calum Douglas for taking his time to give you and me a great little introduction into GM-1 and MW-50. I hope you enjoyed it and perhaps learned something from it as well. If you enjoyed this sort of segment with a guest speaker, please feel free to let me down in the description, in the comment section actually. I might do some more of those, and if you have any thoughts and feedback on this episode, please leave them there as well. And if you're interested in the book, it is available now. As I said, I bought my own copy back in April. This is not a review copy or anything, and I'm reading through it myself at this moment, as you can see. There are 2 links to the book in the description below. One is to the publisher website, one is to Amazon. You will see a price difference between those. However, if you buy it via the publisher, the author will get a better cut. It is of course entirely up to you whether you buy the book or where you buy the book, but I thought I'd mention that just in case you're confused about that difference there. In any case, once again, thank you very much to Calum Douglas for his for sending in his video segment, and thank you also to you for watching this video. And if you are enjoying these sort of videos, please consider supporting via Patreon or channel memberships, because that supports this channel. And for example, it also allows me to buy books like this one and all of the other ones as sources for upcoming videos. If you enjoy the show, please also consider supporting by sharing this video. And as always, have a great day and see you in the sky.